All right. Hi, mathematicians. This is Mr. Fletcher. It's been a while since I've made a video, so this will be focused on solving quadratic equations where you have a coefficient that's something bigger than 1 or other than 1. And so that just makes it a little bit more complicated, and it's going to require factoring as part of solving. So let's get into it. The first thing I hope you noticed is that this should be equal to 0 before we start factoring. And it's not right now, so we're going to have to subtract 19x from both sides. This just gets it in the format that we can start factoring. Okay, so here we have a trinomial, and you'll notice that we have a leading coefficient of 4, which, you know, there's not a ton of possibilities of how you get 4. You can have 1 and 4 or 2 and 2. But then because you also have the constant value of 12, you know, there's a lot of factors of 12, so it can just get a little bit complicated. So here's going to be our strategy, which you saw briefly in the notes, but I think it's easier to see it demonstrated. So what we're going to first look for is what's the product of our 4 and 12, so our A and our C values, and 4 times 12 is 48. So we're going to be looking for numbers that multiply to be 48, so we'll put times to be 48, and then they are going to add to be negative 19. So add to be negative 19. So I just kind of rattle through in my head 1 and 48, and obviously some aren't going to work, so I just go through it just to kind of check them on my list. So 1 and 48, no. 2 and 24, that's not going to work because they're not 19 apart, so we're looking for things that are 19 apart. 3 and 16, well, I guess those aren't 19 apart, but they're going to add to be negative 19, so 3 times 16, and because it's a positive 12 and a negative 19, then they can both be negative, and negative 3 plus negative 16. So that works. So that's our first step. We've identified the two numbers, and now the area model method, I think, actually makes this easier. You don't have to use this, but this is how I'm going to demonstrate it. So what we now have here is we can rewrite our trinomial into 4 terms. So we have our 4x squared, and then we take our negative 19x and we break it into negative 3x plus negative 16x and then plus 12. And those 4 terms go in the 4 squares. And as long as you have your first term and your last term in the top left and bottom right corners, then the x terms, turns out, can be interchanged. So it could have been negative 3x in the top right or in the bottom left. And now we just need to sort of look down the line and see how are we going to get our different combinations to work. And so, for example, and I might need to erase some stuff here, but for example, you could have a 4 and a 3, and that's how I'm going to get my 12. And then how am I going to get my 4x here? I could have a 4x and an x, for example. And now let me just check that. So if I go down, I get 4x times x to get 4x squared, 4x times 4x, but that's going to have to be a negative to make that negative 16x squared, and that's going to have to be a negative to make that negative 3x, and positive 12. So it works. So these are my factors now. So I can rewrite that up here. I now have 4x minus 3 times x minus 4 equaling 0. So remember, that was just the factoring part. That's actually usually the hardest part, because the solving part now says that either the first factor is 0 or the second factor is 0. So I have to consider both possibilities. So I can say, well, maybe 4x minus 3 equals 0, or x minus 4 equals 0. And then I solve each of those independently. So 4x equals 3. And then divide both sides by 4, and I get x equals 3/4. And then over here, that's an easier one. Add 4 to both sides. So, or x equals 4. And that is my answer. Hope this helps. If you loved it, smash that subscribe button.